All right. Hello, everybody. Thank you for attending this August meeting of the San Francisco Bay Area PostgreSQL Users Group. I'm Susie Hazler. I'm one of the organizers, and I'm very happy to have you all here today. And I'm delighted that we have Andrew here to talk to us about table partitioning. So just a few things quickly. This session is being recorded. If you turn on your camera, you will be recorded. I've set it to active cameras only, so if you have your camera off, you're fine. This will be recorded, and we'll have a video up on YouTube, and we'll share that information once it's live on YouTube. If you turn on your mic to ask a question, the sound will be recorded, but if your camera's off, you won't be recorded, just your voice. Andrew is willing to take questions during the presentation, so you can use the raise hand or send a ping to the organizers in chat, and we'll get your question to Andrew. You can either type it out or we can call on you. You can unmute and ask your question. If you don't ask a question, then you aren't recorded. Again, if you don't want to be recorded, type your question. The organizers will convey it to Andrew. If you have any technical issues, please message the organizers for assistance. If you drop out of the meeting and are able to get back in, send us a message on the event page at Meetup. We'll be monitoring that during the event, but hopefully we won't have those issues. I know that certain parts of the country are having some really bad storms and people are having problems with electricity and internet, but hopefully it'll hold up for everybody's presentation, for the presentation. The San Francisco Bay Area PostgreSQL Users Group is affiliated with the United States PostgreSQL Association. We thank them for their sponsorship and their support. As a disclaimer, I'm also the president of PGUS, but these two things are related. Our other sponsor is PGX Inc., which is a San Francisco Bay Area Postgres consultancy. They provide all the video support, recording, editing, and posting. Thank you, PGX. As a note, I also work at PGX. Again, unrelated, just want to make that clear. So I think we have all the housekeeping out of the way. So Andrew, I'm going to turn over to you and make you the presenter. There you go. And I'm going to switch it to just you. So when you start talking, you'll be the camera. And so again, thank you for joining us today. And over to you, Andrew.
Great, thank you. Yeah, happy to be here. Is the microphone volume okay?
Yep, we
Sounds
can hear
good.
you.
Okay,
Yep.
cool. Yeah, thanks for joining, everyone. I see lots of familiar names in the attendance list, which I really appreciate and am excited to see. This talk is about table partitioning, and I think I have found that I enjoy the process of enjoy advocating for more usage of it. I think particularly amongst developers that don't have database administration backgrounds, I think it's an underused capability, and it's a common problem where you have these common challenge where you have high growth databases, and it can be part of a solution to manage that. So that's part of what inspired this talk. It was given back at PG Day Chicago in April. For anyone that's unfamiliar with that conference, I believe it was new this year, and it's a single day Chicago, it's located in Chicago, single day Postgres conference. It was really good. So I'd recommend that. I believe, maybe they'll do it next year. I'm not totally sure, but it's worth checking out if you're interested. And I have the original presentation that you're seeing now on Speaker Deck, and you can download the PDF. The links don't really show up as HTML well in the presentation, but you can download the PDF, and a lot of things are linkable. It's a little bit easier to explore that way if you'd like. I did make some amendments to the original presentation for today, some things I thought would be useful to add in that weren't part of the original presentation, so let's dive into that. Also, I wanted to thank Elizabeth Garrett Christensen for helping connect me with this group. Appreciate that. And she's on Twitter at SQLLiz if you haven't connected with her. Thanks to the SF Bay Area Postgres user group for hosting me. And let's dive into some concepts. So I know for myself, I was confused about partitioning and sharding, and I think they get used sometimes interchangeably, or for, possibly in other database technologies, there's more overlap in definition. So I thought it might be useful to just briefly touch on this. What is sharding? How is it different? So sharding is really not partitioning at all. Partitioning means something very specific in Postgres. And again, I guess I also want to mention too, I'm kind of starting out with the assumption that most people in here are proficient with Postgres database, and this might be a review or a refresher for you, but I don't know the whole audience, so this is just kind of to set up some context. It'll be brief. So um, yeah, partitioning is not sharding. They're different things. And coincidentally, the PostgreSQL Friday blog post series, which if you're unfamiliar with that, kind of a cool monthly blog post series on Postgres. This was the recent topic, I guess, for this month. So there's a link here, and a lot of folks have written, I believe even some people in this call have written up a blog post on their blogs about this topic. So they might tie it back to their personal, uh, where they work and how it's relevant to that. So if you want to expand the scope of these concepts, I recommend checking that out. So sharding as a verb would be the definition that I use would be a database that's distributed amongst multiple nodes, or in Postgres an instance, or a server instance. So a shard might be on one instance. And we're not going to be talking about sharding. Sharding isn't a native concept. There are, of course, other ways to achieve a distributed Postgres topology or environment, but that's going to be outside of the scope of this talk. So we're going to talk about partitioning. And partitioning, in a nutshell, if you're not familiar with it, the most simple way to explain it to for myself anyways, would be basically taking likely starting from an existing large table and splitting it up into smaller tables so that the smaller tables are easier to manage. And although it is possible to start with a partition table, if you know that your use case really fits well with partitioning, you might start that way. Although I think in practice, most of the time, folks are starting with a very large table that's become difficult to manage, and they're reaching for partitioning as a possible solution. And this table, once you've created a partitioned table and you've added partitions to it, you've created this child and parent hierarchy. They're all going to be on the same, in the same database, and that database is going to be on the same instance, just to kind of set up some, kind of bring that back to that sharding concept. So we're still just talking about one Postgres instance. And let's dive into partitioning a little bit more with terms. So prior to Postgres 10, you could achieve partitioned tables, but you need to kind of roll your own with trigger functions and inheritance and a check constraints and a number of different other things. And I haven't personally implemented that setup. I've only really looked at some examples, but in Postgres 10, Postgres created a native concept, and it's called declarative partitioning. So it's built into Postgres. And then what's cool is in every version since, there's been enhancements to it. So declarative partitioning, if you're looking to work with partitioning today in 2023, you'd likely go for declarative partitioning. There are some folks that might be using trigger-based partitioning. They're probably going to know really well exactly what they're doing and have good reasons to do that. And then once you've decided that you want to reach for partitioning, let's look at two tools. There are other tools as well. pgpartman is one tool that we'll look at a bit, and then the presentation is actually going to focus more on pgslice as a tool. So as I mentioned, we'll talk about Partman a bit on the next slide. Trigger-based, we kind of discussed, it's not native to Postgres. Prior to Postgres 10, it was the way to achieve partition tables. Declarative partitioning, yeah, I believe we've covered each of these points already. So Partman, I'm not an expert on it. I've just started looking at it myself. I'm mostly interested in growing my knowledge with it to understand better other partitioning implementations. So it is implemented as a Postgres extension. It also uses the PG jobmon extension if that's installed and configured. And it also supports both an offline, where you take, you stop Postgres and you do a data migration, or an online migration, which we'll be discussing. And there are some different approaches you can do with this. I guess it helps you do these approaches where you might, instead of doing a lot of row copying, which we'll be discussing in the presentation more, you might start with creating a partition table that matches the schema of your current table, and then attaching your current table as a default partition to that new partition table you've created. So one thing I really like about pgpartman is really extensive documentation, also going into different use cases and scenarios and different data migration types. So definitely check that out if you're not already familiar with it. And I do want to also plug, I made sure this was cool with the organizers. I'm writing a book on Postgres aimed at Rails developers. It's actually coming out in beta this month with Pragmatic Programmers as the publisher. So you can check it out at pgrailsbook.com. And currently I'm sending out some sneak peeks to people with some book content covering the Ruby gems and extensions that are mentioned in the book. So yeah, that's kind of the background. Let's get into the original presentation. Everything good with that so far? Just want to check the chat and whatnot.
So far, so good.
Okay, great. So yeah, I guess Twitter is called X now, but if you go to Twitter or X or whatever, you can find tweets that I think it was mostly just me. I don't know that anyone else took me up on tweeting at this hashtag, but PartPG2023. You can find some tweets from PG Day Chicago. I did change the title of the talk from partitioning concept to reality to partitioning billions of rows without downtime. I thought this would be a little like splashier or more exciting. On our largest database, we had about 2 billion rows, 2.5 billion. And I'll talk about the different databases a bit more. And we did do an online migration. And where I work, that would likely be the only way we could really do this. We do run a business, a B2B software as a service application with customers in the US and in Europe and in parts of Asia. So it's really hard to have a low activity period where there aren't some customers online being affected. And it's also quite difficult to communicate with all the customers in a multi-tenant environment to coordinate downtime. So we really wanted to go for an online migration, and generally that's always our default approach. So here are some sponsors from PG Day Chicago. I did ask the audience who had used table partitioning. I'm not sure if we can do this poll on the chat or not, but I was curious if folks had done a table partition migration or conversion before, and whether anyone had used PG Slice. I don't know if anyone wants to write anything in chat. Any brave volunteers? Okay, got some answers. So Nick says yes, yes, no. Okay, so Nick has done table partitioning and has done a migration from an unpartitioned table to a partitioned one and has not used PG Slice. So PG Slice, we'll get into some more answers. Yes, yes, no. Okay, makes sense. Yes, no, no. No, no, no. All right. Daniel, no, no, no. You've come to the right spot, Daniel, hopefully. Hopefully this is useful information for you. Okay, cool. Thanks for that engagement. So I did give a super, super brief introduction to table partitioning. These bullet points are all links though, if you want to download this PDF. Crunchy Data has this playground online, which is, it will boot a Postgres instance, and it has exercises where you can partition a table yourself. And it's really cool. It's a great way to learn interactively. It's how I prefer to learn. I always like to create examples locally and create a table, fill some rows, move stuff around. For me, it's the only way to really learn the concepts and have it kind of retain it long term. So you can do that pretty easily with the playground, or you can, of course, create some of your own examples in a local Postgres instance. But here's some links for learning more about it. So we will cover table partitioning a bit more. So let's just move on to the next slide. So okay, so the outcomes that I'm hoping you take away from this are to learn a little more about table partitioning and specifically the types. We talked a little bit about the history so far, and the majority of the presentation will really be a case study where we partitioned a big table, and I made some mistakes, and I want to tell you about them, and you can take that information and hopefully not make the same mistakes. And then a little bit on cost management if we have time, and how that connects to partitioning. So as I mentioned, where I work is an HR or human resources tech app, and it's a B2B app, software as a service. Customers buy it to do high volume hourly worker hiring, and so we have a lot of data related to applicants, people trying to find jobs, and then on the user side, besides applicants that are applying for jobs, we have recruiters and hiring managers, and they're using this tool all the time. And primarily, we have a number of different apps, but our primary app is a monolithic style Ruby on Rails app. It's 7 or 8 years old. It does have very good test coverage, which I'll talk about later. And it runs Ruby on Rails 6.1, which is relatively recent. We're using this public activity Ruby gem, which is mostly we're just using it kind of off the shelf. And what it does is it creates this activities table, which is not partitioned, and it captures activities records based on what's happening for users as they use the system. So it's kind of an event log or a time series or time-oriented kind of data, and it stores like a lot of data. It becomes quite a rich data source for all of the activity that's happening. And there are some things in there that I don't care for, but it's creating a large text blob as YAML compatible string and storing that in the database. And then there also are a lot of volume. It's a pretty high volume table. Most of the applicants, and we process millions of applicants, will have around 40 records in this table corresponding to things that are happening for them as they use the application. It might be hiring related documents, messages, interactions between a hiring manager and an applicant, that kind of thing. So yeah, errors in this, if we mess up and writes into this table or queries to this table break, it's a really highly visible type of error. So just a small screenshot from the applicant profile. So we can see here that there's a couple of events. They're grouped by day of the week. And we can see one that says opted out of SMS or tax form sent, that kind of thing. Just as a little bit of an example of what this data looks like in the app. And this table is an active record migration. Active record is the framework, the ORM framework for Ruby on Rails. And you write Ruby code and it generates SQL DDL statements. So what this is a migration that you would get when you install the gem. You would generate migrations for the Rails app and it would actually set up this table for you. So it's a Ruby gem that also includes some schema changes. And this is the open source version. So there's nothing in here that is specific to our company or our usage. So it's just to show you a little bit about the table and some indexes that it has. And then on the Postgres side, we're running 13, a number of different minor versions. Fortunately, we haven't really nailed down. We have a very small team that manages Postgres, and we haven't really managed to keep everything in great sync. We have a lot of challenges, whether it's DDL or versions and that kind of thing, or other kinds of cluster level objects. But the way it works is we have a mix of multi-tenant and then single customer environments. So in the multi-tenant environments, of course, as you might guess, we have multiple customers that are using the same application and database. And then we have some customers that are paying for their own dedicated infrastructure, and the company operates that. So that's the full stack of apps and its own database. So this activities table exists around 10 times, and the smallest side is about 50 gigabytes at the time we started this project, and the biggest one was about 1.5 terabytes. And between all the instances, we use AWS. If you're not familiar, has a couple offerings. Regular RDS is closest to kind of community or open source Postgres. And then there's also Aurora, which is AWS's kind of shared storage variation of Postgres, and we use both of them. And there's some details about the number of rows if you summed up all of them, and also primary keys. So I think we'll talk about that more as well. But the table when we started was just your traditional ID integer, or I guess it was a big int column, big int column, that's your primary key for the table. So what were the problems we were facing? Why did we choose this? We actually had a couple partitioned tables, although I didn't personally conduct it in those other earlier instances. We had some partitioned tables elsewhere related to like our webhooks and that kind of thing that are also kind of high ingestion rate or high write rate tables. So activities had become very large, and the original motivation really wasn't as much around query performance. And I certainly thought that when I started with learning and using partitioning that query performance might be the main emphasis, but it actually really wasn't in the end either. It was more about making modifications to the table, and it was certainly somewhat about query performance, but being able to add indexes or constraints, and really just working with the table was kind of the main driver initially. Um, we did replicate content from it using logical replication into our analytical database as well, and we did have some query timeouts there. So there was some idea that once we moved to a partition table where partitions are smaller and they have smaller indexes that cover just a partition and that sort of thing, the analytical use cases would be improved. But it was a little bit of a hoped for outcome. So yeah, we had been writing rows into this table since about 2015, and it was one of our highest or one of our largest tables within the database. There's also a cost opportunity here. So we had some ideas around how the application actually only really needed limited amounts of data from the table. And the table also contained sensitive data. So in terms of a sensitive data handling or a PI handling process, we wanted to explore trying to purposefully limit the amount of data that we retained in the main Postgres database. I'll talk more about that as well. But again, being able to modify the table easily was one of the main drivers. So we looked into table partitioning, and I know one of the questions I had and others have is, well, when do you partition? A lot of folks have big tables in their database, but when do you start to get benefits from table partitioning? And what I found is in the Postgres documentation, there is a rule of thumb, which is to look at the memory that's on your primary instance. So let's say it's 384 gigabytes. And then compare that to your table size. And they suggest if your memory or if your table size exceeds your memory on your main instance, maybe that's a good time. Postgres FM is also a weekly Postgres podcast, which I'm a fan of and recommend. And they had an episode on table partitioning. And on their episode, they recommended considering 100 gigabytes as kind of a rule of thumb threshold. And so the idea with these rules of thumb are that they might be the point where you start to experience the benefits from having a partition table, because there's certainly some upfront costs you'll pay, which is going to be time. You're going to have to perform a data migration, and there's going to be some operational challenges with that. So you want to wait until it's going to be beneficial to unless perhaps if you do partitioning really regularly, you've got a really dialed in process for it. But if you're just getting started, you'll likely want to wait until you're going to really receive the benefits. And there was some pushback in where I work, and there might be some pushback depending on how your team and we don't have a big team of database folks. We have mostly an application-oriented team. So investing heavily in Postgres always requires a little bit of it's reasonable, but some scrutiny and some justification and explanations. A past engineering manager I worked with had mentioned that they, had avoided partitioning in the past because it was too much work. And I think, not sure, but I think perhaps they were talking about some of the older style of partitioning, non-declarative partitioning. And there's a lot more code that you need to execute that, and there's more to maintain and that kind of thing. So I do kind of think with declarative partitioning, it has made it much more accessible compared with the older style. And I think it's really lowered the overhead on getting started. We'll see some examples coming up. But that being said, we still wanted to try to make this change and feel confident that we were going in the right direction. Pardon me one moment. excuse me. So yeah, we didn't want to go down a path of planning to partition the table, do a big data migration, and then find out that it was not a decision that other folks were on board with, because it is harder to reverse at that point. And we also wanted to, use this as an example and create a new approach for how we manage these high growth tables. So we looked into what the application actually needs, and we kind of came up with a hypothesis that 2 years, we weren't sure where to start exactly, but we came up with, me and some other engineering folks came up with the idea of 2 years being a really good upper boundary on the, how far back data would be needed in the application for users. And it's difficult to really have, we have, as a software as a service app, we have a lot of hundreds of customers, so it's difficult to really have conversations with each of them. We want to try to make, scalable solutions. So we kind of chose 2 years. But again, going back to, we didn't want to have to reverse the decision, so we kind of used a web application approach to it, and we created a feature flag. And that feature flag, when it was set, would add a limit to the SQL queries where we were fetching that activity data. And then we have this concept that we have this kind of joke term we use on the team of a scream test, where it's make a change, and if anyone screams, then we can use that information to decide what to do. Or if no one screams, then that's also information that tells us that it's likely acceptable. So we rolled out this feature flag, very easy to reverse. We could unset it quickly. It removes the SQL query limit. And actually, after many weeks, no one really complained. So we felt good that this would be a good product change, and it would be acceptable. And we decided to move forward with partitioning. So now we can get into table partitioning. So table partitioning, you have 3 types available: range, list, and hash. We selected the range type because our use case was we only really needed recent data for the table, recently inserted data. We didn't need data beyond 2 years. And we wanted to take advantage of, because of that 2-year, max old boundary, we wanted to then take advantage of that, and say for data that is older than 2 years, we actually could remove it entirely from Postgres. And so to achieve that, we decided on monthly partitions. And the tool we used helps make it easy to set up, any kind of interval of time that makes sense for you. You might accumulate so many records that you'd want to have a daily partition. And so in that case, you'd set up your partition constraint to just be a single day. But you could do weekly, monthly, annually, whatever really makes sense for your application. We did monthly because then that way at month 7, say, we'd have 1 month that would be older than 6 months old, and then we could decide what to do with that, and a couple of specific tactics to remove it from Postgres. So again, we used declarative partitioning. It has 3 types, and you don't need to do a lot of the things that you do prior to declarative partitioning to achieve this kind of hierarchy of tables. And then I do have a couple slides here on improvements that were added. So the default partition we'll take a look at in an upcoming slide. That was added in 11. And then more constraints were added in 11. Primary key, foreign key, indexes, triggers. So that actually was a really big improvement to make it much more like a regular unpartitioned table. And then something else worth calling out, when you have a partition, it needs to have a compatible schema. So, same columns, same types, etc. You can actually, you can attach it and detach it. So those are the verbs that you'll use to attach and detach partitions. And as is the case with a lot of table modifications, there's going to be a lock on the table. So fortunately, each of those over time gained the concurrently option support. So you can attach and detach concurrently, and that's going to allow you to run those operations and allow other queries to the table to not be blocked, or to at least shorten the, or to at least reduce the likelihood of that. And then another thing on 15, there's a Percona blog post that explains how partitions can be vacuumed in parallel. So instead of one, my understanding is instead of one vacuum worker process per table that auto vacuum might schedule, There can be up to, I guess, based on your maximum number of workers that you have configured, there could be multiple running in parallel on different partitions. And that if you have a mostly insert only or append only table, that might not be super useful if you're not doing a lot of updates and deletes in those partitions, but it will actually still run, it will still actually collect and update table statistics. So it could be useful for the analyze piece. Okay, so PG Partman we briefly covered, and that's in part to because I think most Postgres folks are familiar with that, and that extension is widely supported on cloud providers and that kind of thing. There's also PG Party, which is another Ruby, I think it's Ruby-based open source project I found. With familiarity with partitioning, and if you kind of manage your table schema in your application and that kind of thing, you might just roll your own entirely without a library code. So there's a couple of blog posts that talked about that. And then there is a Ruby command line client called PG Slice that we're going to look at, and that's what we ended up using. So I selected PG Slice because our team is actually mostly a Ruby on Rails development team. And what I found was the PG Slice code, it's pretty small, and it's mostly just setting up, it's using some well-known command line program structure, and then it's mostly a mechanism to generate some SQL statements. So the code itself is very readable, and I also like how it encodes some good practices as how it kind of recommends you go about your online migration. So for example, you have a kind of non-destructive approach where you create a new partitioned replacement table as kind of a clone of your original table, and then you do row copying. And that ability to have a completely separated table, as long as you're okay with the work of doing the row copying, which the command line, the program provides a command for, then the nice thing about that is you have that ability to say, oops, we found something that is a really severe problem, we need to roll back, and you can do that because you have that rollback ability by just going back to your unpartitioned table. But we'll talk about why you want to talk about how you can avoid that in an upcoming slide. But and then it has this conventional, like, these conventional names can help sometimes too when you're just starting from scratch. So it calls the original table once the new partition table has taken over the name of the original table, it calls it a retired table. So PG Slice, again, small Ruby-based command line program. You can run it as a Docker image if you don't do anything with Ruby and you have a container-based deployments. You get these commands with it: prep, add partitions, fill, analyze, and swap. So prep is going to kind of be like a clone of your original table definition. And once you've done that, now you have your target table that you're gonna that's a partitioned table, and it's going to use your table definition from your original table, which we'll talk about in a minute regarding primary keys. You might not want to take it exactly as is. And then you can add partitions to it. And this is going to, again, it gives you some convenience methods on the command line where you can say, I want monthly partitions, and it will set that up for you. It'll set up the constraints for each month's partition that then gets attached to that parent table. And then fill is actually the command to do the row copying. And it gives you some nice convenience methods where you can give it a where clause, and you can do batched copy operations, and you can throttle it down if you want as well. We'll talk about that more. And then finally, you want to analyze all the partitions to update statistics. And the very last step is a swap in a transaction that moves the table names around. If you're setting up PG Slice in a Ruby project, you'd add it to your gem file, you'd set up a bin stub. We ended up adding just a plain Ruby helper class to kind of encapsulate some of our invocations so that we could test it the same way in development and then in production, and also make it easier to share the command invocations amongst multiple developers. Ruby on Rails gives you an option to run programs on the command line as well with the Rails runner, so we took advantage of that. This all being said, and even outside of PG Slice, but there are some row copying, online migration things to be aware of and warnings. And this is going to be outside of even this is really for any kind of bigger volume copy operation or import operation. I guess actually though, I'm reading the first bullet point. There is one here that's related to PG Slice. So the first one is, it is intended for append only or insert only tables. If you have updates and deletes, they're not going to be, there's nothing in PG Slice that's going to bring those forward for you based on the time where you've started the copying process. You'll need to have your own solution for that. So we did end up writing some queries to detect, just a basic way to detect updates. And then we also do soft deletes of the rows, but we didn't have any of those in the time period. And we had really minimal amounts of updates. But in general, with row copying, online migrations, you're going to need a lot of additional storage space. Of course, you're possibly going to double the size of what you're consuming, and it's going to add a lot of load on your instance. So, more CPU, a lot of disk I/O. It's going to also, if it's a replicated table, and it's a logged table, it's going to create a lot of wall and transaction log that's going to need to be consumed. So we'll look a bit more at that, I think, in an upcoming slide. So the other thing I wanted to try to do was I wanted to grow this partitioning approach with developers and make sure we didn't have this schema drift problem where in production we had partition table and in development it was unpartitioned. And this is kind of still playing out where I work, like whether this is valuable, but because partition queries, you really want to have the partition column in the query in all of the queries. So for example, we partitioned on the created at timestamp column. We want to make sure created at shows up in all of the queries for that table. Because you can have those query differences, ideally you have the same table definitions in production and development. You don't have this drift problem. However, we didn't really want to have developers worrying about partitions necessarily. So I had an idea to use a default partition just in development, which does create a difference, creates some drift. And we might actually abandon this strategy and just do partitioning in local development. But at the time, it seemed like a reasonable compromise between having partition table and unpartitioned. So the table is still partitioned locally, but there's just one partition. That being said, the default partition is likely something you don't want to use in production at all because it doesn't have that time constraint or that partition constraint boundary that is really the main purpose of what you're trying to do. You're trying to divide up a table into segments that are non-overlapping and that capture a particular value. So the default partition, it's useful in some kind of like as a holding area or a staging area, something like that, but it's not something you likely want to have as part of your production setup. And then with PG Slice, there isn't actually much on the way of partition management. So as you'll need to create partitions in advance of when you'd write rows into them. And then also as the partitions age out, you may want to detach them as we discussed before, which opens up the option of dropping them entirely, truncating them, or archiving them. And those things aren't included with PG Slice, so you will need to do those yourself. If you want to look at PG Partman, there's some more capabilities there. This is what it looks like in the code, and this is actually using an open source Rails application that I have. It's on my GitHub account. It's called Rideshare. So it has this trip positions table. It's also partitioned with PG Slice. And the main purpose of this slide is just to show you an example of what that is looking like. Here's an example running Rails runner and then calling some PG Slice code. And we did add a bit more things. We kind of made a retire unretire concept for that default partition as we move things around. And then we have different Postgres schemas. So this is not the structure of the table, but the actual schema object. We do have some drift where between the prod databases, we have different schema names. So we added a customization point there for that. And then a couple other small things related to the archival. And I have some of these things added to that open source version of PG Slice also, that fork with some additional changes. Um, okay, so one thing I learned from this project was you really want to get, and I've seen other folks mention this as well. If you have, you have your application, which is your client application working with Postgres. In our case, it's a Ruby and Ruby on Rails app. You really want to get. I mentioned before we have around 90% of the code covered by test code, like line coverage. Um, that's an asset for things like this. You want to get as much information as early as possible about application code level compatibility with schema changes. And the idea with partitioning is that it should be low impact in terms of you should be able to add a partition table to your and not have major application code incompatibilities. And I think that is mostly true. We did have some incompatibilities though, and so to get that information quickly, our test suite and our continuous integration um, service helped us get that information without needing to do a lot of manual testing. So we use Circle CI, and here's just an example of what that looks like. This is actually an example using the open source rideshare app I mentioned. So we set up the table, and then we created a shell script that would then, since we weren't yet, we kind of wanted to do this additive approach to start and this conditional approach. As we rolled this out to all 10 of our databases, they weren't all partitioned at the same time. We went one by one actually, and so we wrote in the details into a shell script that would perform the conversion. And this is important in our test environments because our tests themselves will actually, they depend on the schema or the table structure being there. The test then, the integration style test will write row data in and then query the data, that kind of thing. So we needed to have the test running on the partitioned table. Yeah, and we did find that it wasn't a completely seamless experience. And there were even some things that people didn't realize were happening in the code mostly because the code was old and even older than most of the people's time at the company. Like we did find that some of the rows were being updated. There was some use case where this big YAML blob of data was being queried. So we were able to find that with tests that were updating the row, and then we needed to make sure that update statements would work correctly. But eventually we worked through all of the bugs. So here are some of the code compatibility problems. With a partition table, you have to have, you can't just have your ID primary key as your primary key because you're partitioning on another column, like in this case anyways, the created at column. And that column needs to be part of the definition of the primary key if you have a primary key defined on the parent table. So initially we actually didn't do that. I'll talk more about that if we have time. And we had to actually do a primary key conversion on the partition table once it was already in production, which was a little bit of a nightmare, but save that for if we have time. So what we started out with was we had primary keys defined only on the child partition tables. And that kind of confused active record in some spots. We needed to tell it where the primary key was, like the primary key column. So that was one issue. Another issue was we used this other Ruby gem called active record import. And what that does primarily is it generates multi-line or multi-row insert statements. So just it has a bunch of capabilities, but the way we were using it was at the time to do kind of bulk inserts. And we wanted to continue using it, even though there are actually some functionality in active record to do bulk inserts. And the SQL that it was generating from the Ruby code wasn't compatible with the partition table. So we needed to make some changes there. So yeah, we did set some primary key configuration. We also we actually did replace the active record import code with insert all, which is part of active record. And we needed to accommodate like I think we were doing, we needed, because of how we had the primary key constraint set up, we needed to have a uniqueness definition. So we added a unique index to create a unique constraint on a couple of columns for the purposes of that insert all statement. So those are kind of the initial code compatibility changes that we needed. And again, the process was to identify the failing tests, go and identify the code that's being tested, make changes to that application code, push a new build until we got all the tests passing. Another funny thing was that because some of this test code was written older than 2 years ago, so it could have been a test written for 2018, and some folks had used hard-coded dates in those tests. And what we were doing with the partition conversion is we were only creating 2 years worth of monthly partitions. So what happened was pretty clear. If you're familiar with partitioning, the insert would fail because there'd be no matching partition for it. So we needed to go through and update those tests. Probably a good idea anyway, but to use relative times. Typically they didn't need to actually be inserted in 2018. It just happened to be the current time at the time the test was written. Okay, so we got everything working and we were ready to go. And PG Slice has you set up an environment variable, which is a connection string to your Postgres instance. And then we had already prepared the structure changes in advance with that prep command. So all the target side table was there. All the partitions were there. And we were able to test a bunch. Besides the automated developer testing, we did pre-production testing on lower environments like our UAT environment or staging environments. And we were able to feel really confident about the steps we were going to run, kind of rehearse them. I always think that's a good idea. Discuss it with multiple team members, provide a lot of notice that, hey, we're going to be doing this online migration, time it for a lower activity period. And this is just one screenshot I grabbed. I think it was from an RDS instance, just showing, a lot more CPU usage while the online migration was running. If you don't remove indexes on the target side, for example, you're also going to be doing index writes, and constraints will be checked, that kind of thing. So we did typically run it in like a screen session or a tmux session, and this is kind of a look at what the SQL statements will look like. It's just doing batched copying. It's doing an insert into, which is the target side table, and then it's selecting rows and batches by ID range from the original table. And this can be throttled down if needed and that kind of thing. We were monitoring, closely monitoring the load on the instance. And then, finally, the last step is the PG slice swap. So that opens a transaction, renames the original table to be a retired table, renames what was the target table called intermediate. It takes over the name of the original table and it commits that. So in one transaction, the table names are swapped. So how I said before that we had a pretty strong signal that 2 years of data would be okay. Well, actually, after this all happened, one customer did really want more than 2 years of data, and we did end up accommodating them. And they were in a database where what we did was we essentially added more partitions back. So we went back based on their specific data. And they're an important customer and someone that has been a customer for many years. So we kind of did this just for them, but we basically added another number of years of partitions, and then we filled just their data into those partitions. And that was something we didn't plan to do, but ended up working out okay, and they were happy again. So to do that, I was actually looking at this last night. I kind of don't even remember I think what I was trying to communicate on this slide is just that we wanted to select just their data from the table, but we didn't want to have we wanted to isolate it somewhat. So we created a temporary table that I believe ended up acting as the source table for the eventual fill. And that allowed us to not have any long running transactions on the original table. I think that's what I was trying to show on this slide. And there's some quirks or nuances with PG Slice based on how it's designed. And if you do have to do this multiple fill kind of situation, so, hopefully you don't have to do this, but this slide goes into a little detail about some of the challenges with running fill multiple times based on how the PG Slice code is written. One thing that I did learn in this process though too is if you do have old partitions and you do want to empty them, you can truncate them. And that's nice because it won't cause bloat. And, you might want to leave the partition around for a bit, but empty. And then you can always you could still detach it or reattach it later, kind of depending on what you need to do. So one other gotcha with Ruby on Rails and Active Record is when it boots up, it does keep a cache of the schema, and that's called the schema cache. And we did have this challenge. We have a Kubernetes-based deployment with pods where they would have a stale schema cache at the instant where we swapped the table names. And because the partition table did not have the exact same definition, for example, it had a difference in the primary keys, and it had a difference in an index, a unique index. And we ended up writing some code to anticipated this scenario, because actually it wasn't anticipated, it was found on some testing. But we wrote some code defensively to just handle this kind of 5-minute period as to avoid losing data from writes that wouldn't go into the table, to forcibly catch an exception and then forcibly expire the schema cache. So that would tell Active Record to go and refresh it again. And that solution ended up working well for that period of time before the application pods all restarted. Once they restarted, they had a up-to-date copy of the schema cache, and we were all good on that. And then these are also some kind of generic techniques, but we did use them as we went through 1 through 10 of these databases. It became more beneficial to, especially as we moved up to the bigger ones, to do some techniques to speed up the process. So we would drop all or most of the indexes from the intermediate table that we were going to copy into. We could always go and get their definitions from the original table. And then we would set the table even to unlogged at the end. I think we did this on the last one. That was the biggest one, to speed up the writes further. That did end up, we did need to make the table logged again before we would use it. And so then we did have a big accumulation of transaction log data that needed to be replicated. So, I don't know if that's actually a technique I would use again. It kind of depends on the timing of your actual activity on the instance and how over provisioned you are, and and that kind of thing. But yeah, we did want to make the table log, so we set it to unlogged and then back to logged. We did add all the indexes back after all the rows were written in. So some of the results then, the biggest space reduction win here was really just from, it's not really inherent to partitioning. It's the fact that we could say, instead of data for all of time, which was like 8 years or something, we only needed 2 years. The resulting size of the tables were much smaller, and they also were more correlated. I was thinking about this just before the presentation. I believe they also were more correlated with the correlation was higher between the data on disk and the time based on how we query it. I guess I need to think about that more, but we were writing new fresh copies of the rows in. So there was only one row version. So we were starting out from a good position in terms of bloat in the table and in the indexes, by it being really low or non-existent. But the biggest win, like I said, was just this narrower range of time. So in the biggest case, it was about 82% smaller from where the table started to where it was after it was partitioned. And that lets us better utilize the memory that's on the instance, right? We have smaller tables to work with, and that's helpful. So yeah, I have a few more slides on some of the cost saving side of this, which was part of the original motivation. And I will briefly cover that now. So we have, like I mentioned, we have RDS, Postgres, and Aurora. And from my research on this, the bigger win was on the Aurora side, because with regular RDS Postgres, my understanding was you pay based on what you provisioned, and then we had storage auto scaling enabled, which other cloud providers might have a similar concept. But once you exceeded a threshold, then you'd move up a tier and you'd provision a bunch more storage, and so you'd start paying for that. And if you went down, too bad, you're still paying for that additional storage. There's not an easy way. You'd have to really replace the instance, I believe, with RDS Postgres if you wanted to provision less storage. But Aurora is a little different, where it works it works in 10 gigabyte increments, either up or down. So if you manage to reduce space consumption whether it's from, reducing the number of rows you have, like in this kind of partition table conversion, or eliminating a lot of unused indexes, or whatever way that you've reduced your space consumption, then you can start to save money in 10 gigabyte increments on an ongoing basis. And then on this graph, it's a little weird, but what I was trying to do is show on the top without partitioning and the bottom with partitioning. So without partitioning, you just keep growing and growing, right? If you have a high growth table, and after 5 years, I just did some basic calculations and came up with your tables. You might be consuming over a terabyte of data. But on the bottom, if you imagine you have 20 gigabyte partitions and you're cycling out 20 gigabytes as they age out after 2 years, and you're creating new ones on the front end that are about the same size, your growth is going to be relatively flat. You're going to consume about the same amount of space month to month. And that's kind of interesting as like a cost control mechanism. This might be a very valuable functionality, but it also can be nice to know that it's not going to explode the costs. So yeah, after this process, then after the conversion, the migration, then we had a lot of transitional code to remove. That we had some feature flags to remove, and then we produced. I wrote up some documentation and did some training on the code for developers. And we also wanted to add management or monitoring for the partition management, both for adding new partitions and then on the cycling out old partitions, which I think is just kind of the last bit of this presentation. So as we discussed before, once our use case was we needed 2 years of data, but once 2 years had passed, partitions that were older than that could be retired or archived. So what we thought we would do is automate the process to detach the partition, and then at that point we could dump it into either a CSV file if we possibly wanted to make it easier to consume elsewhere, like an analytical database. We could just drop the partition entirely if we didn't need the table data at all, or we could archive it using the Postgres custom format. So here's an example with pgdump where you might create a compressed dump file, and then you could store this on low cost storage like S3 or some other object storage. AWS has these built-in functions that you can even send data directly to S3, which is pretty cool. So that's really the end of the main presentation. Let's just summarize some of the points. On our biggest database instance, we had about 2 billion rows, and we were able to do an online migration of that original table into a partition table, but with a narrower range of just 2 years of data after we kind of verified that would be okay with the application. And in the best case, that made our tables about 80% smaller, again, mostly because of that narrower size, a bit because of some of the benefits of just doing a table recopying or like kind of a table rebuild, but mostly because of the reduction of the range of data. And then it enabled us to do a regular export process, which helps us both on operations, and it also helps possibly on sensitive data management, just to reduce our liability a bit from holding sensitive data in our primary application database unnecessarily. And then it's part of helping to define our overall data lifecycle management policy and practice that goes beyond just this one table, but really, what is all of the sensitive data that we're holding and how long do we retain it? And partitioning can be kind of part of that whole thing. So on your way out, got a goodie bag for you. I do have a GitHub repo that's called PG_scripts on my account, which is Andy Atkinson. And there's a bunch of queries in there that I've collected over the years, mostly from other folks, and I credit them in the top. And so these are some queries that I used as part of this project to analyze data and make sure things are going on the right path. So you can get links to these, or you can find that on GitHub as well. Special recognition, I thanked the PG Day organizers. Thanks again to the SF Pug organizers for the opportunity to present to you all today. Andrew Kane, the creator of PG Slice, was also a reviewer of a bit of this ahead of time, and some other reviewers. Appreciate them helping me out. So again, you can find me on andyatkinson.com, and you can contact me there. And you can find links to the slide deck on Twitter to go back to that other presentation. Yeah, and feel free to connect with me on Twitter or X or whatever it's called. I'm also on Mastodon, and I even set up a Blue Sky account, which is kind of a lonely place in there, but you can find me there, or the Postgres community Slack. I really like that to engage with folks there. And then the pgrailsbook.com is my current landing page for the book. And in about a month from now, it should be published more officially from the publisher. You'll be able to buy a PDF version of the book at that point. And in the time leading up to that, if you subscribe now, I'm also sending out, like I mentioned, I have 2 more rounds of chunks of the extensions and Ruby gems in the book. So even if you don't really plan to buy the book, but you want to check that info out, if you subscribe now, you'll get that by email. And that's all I got. Thank you again for listening to me today, and I'd love to discuss any questions that folks have.
Wow, that was really great, Andrew. Thank you. It's not being a technical person, I was still able to follow your talk. So well done.
Great, thank you.
Yeah, you're welcome. Oh, we have a question in the chat from Nick. Has the Aurora IO optimized pricing option impacted your strategy around partitioning on Aurora?
Yeah, I saw that. Actually, I think it would. We did this table back in this project was mainly back in March and April of this year, and I'm also cheating, and I see in the URL we can see it's May of 2023. So the IO optimized instances I don't think were out yet at the time, and yeah, I don't have a good answer, but it's definitely something I want to look into. In the community Slack, again, I know that we're mostly focused on open source Postgres, but if you are a AWS kind of Postgres user, there is an Aurora channel in the Postgres community Slack, and there are some folks discussing the IO optimized instances. So I'd probably go there. Increased weights on lock manager post partitioning. Yeah, the way that our main visibility into Postgres level issues, they would bubble up as, likely as blocked queries from our application exception reporting. So we use one, and has a funny name in the Ruby world called Honey Badger. I don't know if folks are familiar with that, but Honey Badgers are application error reporting exception. So like, let's say we tried to write a row or update a row, and it was a blocked query because partition was locked. I think that's kind of what the question means. I haven't actually seen that. We don't do a lot of lock analysis. I do know, and I wrote a bit in the book about, like, if I was going to do lock analysis, like if I was seeing a lot of lock related exceptions, I'd probably try to grab a chunk of the Postgres log file and then use PG Badger to analyze it or to process it. And then it has a nice presentation of lock conflicts and the queries and the block queries and their PIDs. And you can I'd probably try to use that and then relate that back to where the application is and figure something out. That's about the best answer I have for that, though. We didn't generally see a lot of at least write level errors after partitioning. I did also, on the query performance side, I will say, like, we didn't really see much of an improvement on the query performance side of things. We did go through and make sure that all of the queries to the activities table had that created at column in them if they didn't prior to that. And, kind of looking at, we use Datadog as our application performance monitoring tool, kind of looking at some average response times before and after of API endpoints that, where this query was part of it, kind of washed out. It wasn't a big win there, but we did immediately start to solve and made the data folks happy. We do logical replication of this table, which it was good we were on Postgres 13 because it was added for partition tables. I think I mentioned that earlier. the replication problems that they were having prior to the being partitioned, those went away. So replication started working much more smoothly and reliably. So they were happy about that. Yeah, so the next question is about query performance problems after adding created at filters. Did we need to add more indexes? Yeah, I believe that column was already covered by an index. We possibly would have needed to add, for sure, the primary key would be covered with the biggest thing was, and I guess I didn't mention this in the presentation, but it's partition pruning, I believe is what Postgres calls when you supply information about where the row should exist in the partition, then at query planning time and at execution time, I believe, the planner can identify and exclude all the partitions where the row can't be. And we made sure to get some validation on that ahead of the actual production migration. And so for that reason, I don't recall adding any new indexes. And what I've done to experiment with this a bit is you can enable and disable partition pruning, and then there's also a constraint exclusion. But I think partition pruning is the main one, if I remember correctly. You can enable it and disable it, and you can kind of see the effect of it too if you want to play around with it on your local Postgres.
Right. You hopped over a question. Are you able to change the intermediate table definition as part of the repartition exercise, i.e. int to big int?
Yeah, you would need to do that on your own. Like PG Slice, what it does is it basically just gets the table definition and then it does a create table statement with the same definition. So if you kind of use it in autopilot mode, like that's what will happen. And if you don't want that, you'll need to intervene. And, so that actually, it's a good point though, because if you are doing, if like doing a data migration to a partition table could be part of a int to big int migration anyway, or it could be an extra bonus benefit. So what I would do is I might just generate PG Slice there's a dry run option and it will show you all the SQL statements that it will generate. So it'll have a create table statement. I would probably just copy and paste that and modify it to be, big int as my primary key column. And I didn't end up talking about this, but we did have to change afterwards to having a primary key, a composite primary key defined on the parent table. And that's because without that, I've written this up as 2 blog posts you can find on my site if you want, but the gist is that our data pipeline going into our analytical database that would detect row changes in Postgres, without having a primary key, it had to do a bunch of additional gymnastics to find out if a row had changed, like if it had been updated or deleted, basically inefficient queries. And I got together with the data engineering folks, and there were a couple options, but we decided the fastest option to fix it was going to be creating a new primary key. But as you all may know, then if you change the primary key definition, you're going to have possibly a long lock period. And with partition tables, what I found was it's a very long lock period because it seems to be connected to all the child partitions and scanning all of those for compatibility. So on our biggest database, we ended up having about a 30-minute long lock period of the table when we did this. So we did this trickery to actually create a stand-in table while the original table was being modified. But anyway, that you can read more about that. And we did. I think I kind of got sidetracked on that. So we did end up though, and this is the way it's running in production now, is we have this composite primary key on the parent table. So it's got ID and created at in its definition, and that's the same primary key that all of the partitions of that table have as well. I'm going to just.
Sorry, go
on. Yep. So that was a question from Tony about any challenges with active record composite primary key. What I found, this is a little confusing because active record specifically, at least for the Ruby on Rails folks, it doesn't officially support composite primary keys from what I can find, but it also works okay when you're using them. It looks like in an upcoming version of active record, they actually want to I believe they're going to bring in official or native support for it for composite primary keys. There also are some Ruby gems, but what we found was we can write rows into the table just fine. And so there, it's kind of like not officially supported, but not also broken. It works okay. And then John asked, how did you all enable created app for the insert statements? I think what this means, I think the answer for this is we just had to go through and, it was a lot of work, but, make sure that everywhere where the rows were being inserted into the table, make sure that they had the created at defined, that it wasn't being set as like a database column default. I believe that's what we did. We made sure that it was always being set on from the application level and sent as data, and then that way it could be routed into the correct partition.
Great. Did you see the question about any specifics for the tables with toast?
Oh yeah. Yeah, so I think that they're getting at the total oversized attribute storage thing with maybe with the YAML, the big blob of text data column. Let's see, any specifics? Yeah, I don't recall any specifics, and I don't know if I know there's some threshold where Postgres treats it as like a toast column. I think that's how it works. And I don't remember any. Really, what we wanted to do was make sure that the right operations and the queries to the table, even with that bigger sized data as the column data, make sure that worked. And we mostly did that through our test coverage. And then, of course, like we could manually test it as well. But yeah, I don't remember anything specific about that one.
Great. And I think that's all the questions from chat. Unless somebody's frantically, no, I don't see any more. I don't see any typing activity. So that was great. Thank you so much, Andrew. Really enjoyed that, and clearly our attendees did as well with the questions. Oh, we have some heart icons happening. Oh, wonderful. So thank you so much for taking the time to present to us today. It was really appreciate it. So just what's coming up? Let's see. Our next San Francisco Pug, we are skipping September. In October, Elizabeth Garrett Christensen will be presenting. I don't have a topic from her, but I know she's a terrific speaker, so stay tuned. We'll have that live as soon as we have the information from her. We're looking for a speaker for November, so if you're interested, let us know. We'll be skipping December. The end of the year seems to be incredibly super busy for everybody, and so we'll skip December and resume again in January. Lots of wonderful compliments happening in the chat. So definitely check it out before you go, Andrew. Again, thank you to PGUS for sponsoring our meetup. Thank you to PGX for taking care of the video for us. When the video is available, it will be posted on our YouTube channel. We'll send an email to all the members of the PUG and also be on our social media. Other things coming up, let's see, PGConf NYC, New York. Get your employer to send you to New York, October 3 to 5. The schedule is posted. Tickets and sponsorships are available. However, the hotel block closes on September 11. So even if you haven't bought your ticket, book your hotel, because we might get an extension on that. We might not. So just assume that September 11th really is the date, and you need to book your hotel before then.
Stacy, can I interrupt you really quick? I'll be at PGConf NYC as well, and I'll be an attendee. I did submit a proposal that wasn't accepted, which made me sad, but I also am really excited to go, and we'll try again in the future. And there's also a great lineup of speakers. I think the session list looks really good. And I also agree the hotel. I grabbed a reservation there. I would encourage anyone that's considering it to do so because it is a pretty good rate for New York. So yeah, just wanted to add that in.
Great, thank you, Andrew. Yeah, well, don't feel bad. I submitted a talk and it didn't get accepted either. So it wasn't just you. There was incredible response on the talks this year, and only 30 slots. So, but
it was also
keep submitting.
Yeah, keep submitting. And it was actually I'm actually a relatively new Postgres presenter. And Postgres Conference New York 2021 was my first ever one, so just 2 years ago.
Oh,
And
wow.
it was I really appreciated it being a first time presenter there. So it is a great conference, and definitely submit to that. Take a look at PG Day events that are all around the world really too. So yeah, sorry, go ahead.
No, 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 please. No, that's great. Thank you. Lots of people saying, yay, see you in New York. So that's exciting. So again, thank you, Andrew. Thank you to everybody who attended. Thank you to our sponsors. And we'll see you all again in October. All right. Yay. Thanks. Bye.